So what is the probability and odds of getting 2 pair in poker? So this is for simple 5-card draw poker where there are no extra cards and no community cards. You might want to watch our permutations and combinations tutorials first in order to fully understand the calculation. Disclaimer, we do not encourage gambling. Remember, the house always wins. Let's get started. First thing, let's look at what 2 pair actually is. 2 pairs, all right? We get a pair of one card of a particular rank and a pair of another card of another particular rank and a third card which is not the same rank as one of these two, okay? It's got to be a completely different one, otherwise you'll end up with a full house. So what are the number of combinations of getting 2 pair? Well, the first rank we have a choice of 13, 13C, and we actually have to choose 2 ranks for the first pair and the second pair, 13C2. And then for our first pair, we have 4 cards to choose from, and we choose 2, 4C2, and the same for our second pair, times 4C2. And left over, our 2 ranks are already gone, which leaves us 11 ranks to choose from. And if we're doing kings here, we have 4 kings to choose from, we need to choose 1. Question, can we not do 13C1 times 4C2 and then 12C1 times 4C2 for our 2 pairs? Yes, you can, but then you're going to actually have to divide by factorial 2 in the end to undo that permutation. If you want to see a better explanation of that, have a look at our 1 pair presentation. Evaluating this, 13C2, oh, what's that? 13C2 factorial 13 over factorial 2, factorial 11. 13 and 11 cancel, 13 times 12 times 11 factorial cancels there, leaving 13 times 12 over 2, 2's cancel, giving 6, 13 times 6, I might just leave it like that and write it straight in here, 13 times 6, 4C2 is 6, 4C2 again is 6, and then 11C1 is 11, 4C1 is 4. Evaluating that is 123,552 hands, I believe. So to calculate the probability of getting 2 pair, we're going to take this expression here and write it up here. But I'm going to take this expression just for ease of cancelling later on. Number of 2 pair hands divided by, and this expression here is 52C5, the number of possible poker hands. Dividing by this gets inverted and multiplied, and 47 factorial cancels, leaving us with this expression here. And let's see how this cancels out. 5 times 2 will cancel with the 10 here, just leaving 5 instead of 50. 4 times 3 is 12, times 4 is 48. That will cancel with the 48 on the bottom. What else do we have? We have a 13 goes into 13 once, 13 goes into 52 4 times. And we have a 51, 3 goes into 51 17 times, 3 goes into 6 twice. That is it, I believe. It leaves us with 2 times 6 times 6 times 11. That's all there is on top. And on the bottom we're left with 4 times 17 times 5 times 49. Oh, that's not finished. We can go further than that. 2 goes into 2 once, 2 goes into 4 twice, 2 goes into 2 once, 2 goes into 6 3 times. Leaving us with 3 times 6 times 11 over 17 times 5 times 49, which gives us a final probability of 198 over 4,165, which is a probability as a percentage of approximately 4.8%. So if we want to look at the odds of that, for every 4,165 hands, we're going to get 198 2 pairs on average. And doing the subtraction there, that will give us 3,967. Okay, so for every 198 2 pair hands you're going to get on average, you're going to get 3,967 hands that are not 2 pairs. Dividing both sides of this by 198, we get 1 and 20. Pretty even odds there, 20 to 1, okay, are the odds of getting a 2 pair. So there you go, the total possible number of combinations of 2 pair hands in 5-card poker and the probability and odds of it happening.